So the next topic what we are going to see is your multivibrator. Multivibrator using 555 IC. So 555 IC is nothing but it is also called as a timer. Why? What's the reason? Because it produces timing or it generates timing pulses. Okay, so I can tell that this multivibrator using 555 timer, it is a regenerative circuit. Regenerative circuit, okay, which generates timing pulses. So what will be your timing pulses? This will be your timing pulses on and off, right? And this duration of your timing pulses, duration of the timing pulses will be determined by the resistors and capacitors which are connected externally. Okay, so this is your special feature of your multivibrators. So some of the advantages of your multivibrators are, it is inexpensive. So it is readily available, okay? Expensive, it is not expensive, it is inexpensive, then it is very accurate and it has high temperature stability, etc. So that's why we go for this type of multivibrator, okay? High temperature stability. So this multivibrator, 555 timer multivibrator is an 8-pin IC, okay? So 1, 2, 3, 4, 5, 6, 7, 8. It goes like this, okay? 1, 2, 3, 4, 5, 6, 7, 8. So what are the different connections going to these 8 pins? So the first pin will be the ground, okay? It will be connected to the ground. The second one will be your trigger. Okay, it is called as trigger. So this trigger will be connected to the inverting terminal. Inverting means your minus terminal. Okay, inverting terminal to your lower comparator. Okay, and this has three specific function. It will be converted to the inverting pin of your lower comparator, which resets the flip flop. Okay. Now your third pin will be your output. Okay. Now fourth pin will be your reset pin. It is called as a reset pin. Fifth pin is your control pin. Sixth pin is going to be your threshold. Okay. So this threshold pin will be connected to your non-inverting terminal. Non-inverting terminal means your plus. Okay. Non-inverting terminal of your upper comparator, and it will set the flip-flop. So you have three functions here. Okay. Now the seventh pin will be your discharge pin, and the eighth pin is going to be your supply, VCC. Okay, so in this video I'll be explaining only the introduction of your multivibrator so that it is easy for you to study. The next video we will see the functional block diagram of your 555 IC. Okay, so these are the 8 pins. So the first pin will go to ground, second pin trigger, third pin output, fourth pin reset, fifth pin control pin, sixth pin threshold, seventh discharge, and your eighth pin will be your VCC. Okay, so based on the configurations, your multivibrators, based on the most commonly used applications of multivibrators are the two types which you are going to study in your as per your syllabus. So there are mainly three types. Okay, so the first type is called as your Astable multivibrator. Astable multivibrator. The second one is called as your monostable multivibrator, and the third one is called as your bistable multivibrator. So astable, monostable, and bistable. Okay, the name itself gives you the meaning. Astable, or it is not stable. So your astable multivibrator is the multivibrator which do not contain any stable state. So there is no stable states. There is no stable states. Okay. What is meant by this states? States means whether it is on or whether it is off. Okay. So on and off both are not stable. it doesn't contain any stable state. That is called as your astable multivibrator. Since it doesn't contain a stable state, it will generate a square wave pulse. Okay, so it generates a train of square wave pulse. It generates a train of square wave pulses. Okay, which is not stable. So it will be switching on and off in between these two unstable state. Okay, so it is also called by another name. It is called by free running oscillator. It is called as free running oscillator. Okay, so these are the certain features of your astable multivibrator. It doesn't contains any stable state. Now what will happen in your monostable multivibrator? Mono means one. So it is having one stable state. One stable state. And what will be the next state? The other will be your quasi-stable state. Quasi-stable state. The other state is going to be your quasi-stable state. Okay. So in the case of monostable multivibrator, you will be having or you will be utilizing one single trigger. One trigger will be used to change the state. Okay, you are using one trigger pulse. That is a specialty of your monostable. What will be your bistable? Bistable means name itself gives you the meaning bi. Bi means it has two stable states. Okay, so both the states will be stable. So what will happen? You have to use two trigger. Okay, so when you use one trigger, for example, in the case of monostable multivibrator, you imagine that you are applying a negative triggering pulse. So during the negative triggering pulse, what will happen to your output? The output will go to positive, will go high. After some time, the output will come back to its original low state. So this will be your permanent state or your stable state. Now it will be in the stable state until and unless you are going to apply the triggering pulse again. This is the specialty of your monostable. Whereas in the case of bistable, it has both the stable states. So if you want to convert it into your first state, you have to apply the first triggering pulse. So it will be in your on position until and unless you are going to apply the second triggering pulse. So this will be a first triggering pulse, this will be a second triggering pulse. It goes on. Now if I want to change from negative to again positive, again you have to apply the next triggering pulse first. So it goes on. So you will be using ultimately two triggering pulse. Again application of the second triggering pulse, again it goes to the next state. So it will be in this permanently in one state until and unless you are applying the trigger. That is a specialty of your bistable multivibrator. So mainly you are going to study the two commonly used application. One is your astable multivibrator and the other one is your monostable multivibrator. So let me draw the diagram by means of this pin diagram so that it is very easy for you to understand. Okay, so the first one is a stable mode. So in the case of a stable, so your 555 timer, okay, so 555 timer. So what is happening, the common connections I will tell you, the pin 1 and 5. So the pin 1 will be always going to ground, right? Pin 1 is going to ground. Now what is happening to your pin 5? That is your control pin is used to, it is also called as control voltage pin, which is used to control the trigger as well as your threshold voltages so that you can vary your pulse width. That is the output width of the pulse you can vary. But in most of the conditions you will not be using it. So if you are not using it, you have to connect it to a 0.01 microfarad capacitor to the ground in order to avoid any distortion. Okay, now the next two pins are your, let us finish the VCC. Okay, so your 8th pin will be going to your VCC. Along with the 8th pin, you have one more pin that is called as your reset pin. So what is the function of this reset pin is, once you are giving a negative triggering pulse to your reset pin, the output will be going to the low condition. It will be resetting the output. So when this reset pin is not used, it has to be connected to the VCC in order to avoid any false triggering. Okay. So there will be one more connection coming to the VCC, that is nothing but your from the fourth pin, reset pin. So this will be commonly connected to your VCC. Okay. Now what are the other pins left? Now you have to we have seen in the definition that the duration of the pulse is determined by the resistors and the capacitors externally. So in the case of Astable multivibrator, we will be having two resistors and one capacitor. So one resistor, let me take it as RA. The resistor RA will be connected between your 8th pin and your 7th pin. That is, your one connection will go to your discharge. Okay. So the 7th pin. Okay. And the second, this will be your resistor RA. The second resistor RB will be connected towards your 6th pin and your 7th pin. So 6th will be your threshold pin. Now second pin and will be shorted along with the 6th pin. Second pin and 6th pin will be shorted, and you will be having a capacitor connected. So the capacitor will be connected, either you can take it from the 6th pin or the 2nd pin. So this is your diagram of your Astable multivibrator, which consists externally of two resistors and one capacitor. Okay. Now the same diagram you are going to modify a little bit. Monostable multivibrator. In the case of monostable multivibrator, what will happen? Draw the same diagram. You are going to only modify your resistors and capacitor. Instead of using two resistors here, your monostable multivibrator will be having only one resistor and one capacitor. That's all. Okay. So here you will be getting same. First pin will be grounded. Your 5th pin will be given to 0.01 microfarad and it will be grounded. Okay. Now here I have left your 3rd pin is going to be your output. Okay. So here 6th and the 2nd pin is shorted. Now that is the only difference here. 8 and the 4th pin will be given to your VCC, right? Now the only difference what you are going to do is you have the same resistor, only one resistor is connected between your 7th pin and the 8th pin. Till this it is common. Now from the 7th pin you are going to eliminate this resistor RB. So when you eliminate this resistor RB, you are going to short your 7th pin and 6th pin, right? Because you don't have this resistor RB here. Now you are going to connect a capacitor, resistor and capacitor. Okay. Now what is happening to your 2nd pin? The 2nd pin will be going to your, will be applied, triggering pulse will be applied. So what is the use of this? The monostable multivibrator, you have to apply a single triggering pulse. So the input trigger pulse will be applied through your 2nd pin, which is nothing but the trigger. So these are the difference. So 3rd pin will go to your output. Okay. So this will be your both the diagram. So when you see this diagram, you can see clearly that when I apply the VCC, okay, the output you will be getting the output pulse, right? Square wave you will be getting. The output square wave you will be getting due to the charging and discharging of the capacitor. So what will be the two paths? The charging will be through VCC towards C and your discharging part. So this will be your charging path towards VCC. Okay. And what will be your discharging path? Discharging path will be from the discharge pin, that is your 7th pin, to the ground. So this is going to be your discharging path. Similar to that in monostable multivibrator, through VCC, this will be your charging path towards your VCC and discharging path will be towards your ground from the 7th pin. So you have two paths here, charging and discharging. So this is your overall introduction of your two types of multivibrators. Now in the next section we will see the functional block diagram of the 555 IC. That is, what are the components, main components present inside your 555 timer. Okay. Once we complete the functional block diagram, we will go to the next explanation of both these multivibrators separately.